Assalamualaikum and hi there. My name is Hanis Hazita binti Ali. So today I'm going to present to you about the concept of thermochemistry. So this is my team member Nur Ainil Hawa and Nurul Aisha. Let's begin with Aisha.
Explanation on the thermochemistry. A branch of chemistry called thermochemistry studies the heat energy changes resulting from chemical reaction and processes. Heat involves the measurement and calculation of the heat evolved or absorbed during chemical reactions, as well as the study of the factors that influence these heat changes. Enthalpy, a measure of system heat content, is one of the main ideas in thermochemistry. Enthalpy change is a measure of the heat transfer within an environment during a chemical reaction and is defined as the difference in enthalpies between reactants and products. If heat is absorbed, the enthalpy change might be positive or it can be negative. Next, Anis will continue the presentation.
Next, application of thermochemistry in a daily life. Did you know we have it in food and nutrition? So thermochemistry is involved in cooking and food preparations. Heat energy is used to cook food and alter its chemical. For the household energy, thermochemistry is crucial in our everyday energy usage, like combustion reactions in heating, cooking, and hot water system, natural gas, propane, and electricity like conversion of energy for household applications, and efficiency considerations like energy conservation and sustainable practice. Next, environmental impact. So, thermochemistry plays a role in environmental processes like combustion to fossil fuels, release of greenhouse gases, then thermochemical reactions in industries like emission control strategies and renewable energy technologies like solar panels, wind turbines, and biofuels. Next, we go to the transportation. So for the transportations, thermochemistry influence transportation systems. Then, fuel combustion like internal combustion engines in vehicles and energy efficiency like hybrid and electric vehicles, and also emission reduction like catalytic converters and fuel additives. Other than that, we also have chemical industries. So thermochemistry is integral to chemical production processes, then reaction kinetics and thermodynamics like optimization of chemical reactions, energy requirements like heat transfer and energy management, also product purification like distillation, crystallization, and extraction processes. Lastly, pharmaceutical and medicines. Did you know thermochemistry is involved in drug development and formulation? Drug synthesis like energy changes during chemical reactions, and also stability and shelf life like thermochemical analysis for storage conditions and drug delivery system like control release mechanism. Next, we go to the Hawa.
Next, I'm going to talk about the importance of the thermochemistry. Thermochemistry is a very important field of study because it helps to determine if a particular reaction will occur and if it will release or absorb energy as it occurs. It is also possible to calculate how much energy a reaction will release or absorb. This information can be used to determine if it is economically viable to use a particular chemical process. Thermochemistry, however, does not predict how fast a reaction will occur. In addition, thermochemistry combines the ideas of thermodynamics with the idea of energy as substance bonds. The subject usually incorporates computations of such amounts as warm leaving, warmth of burning, warmth of development, enthalpy entropy, free energy, and calories. Thermochemistry can be used in many ways. For example, it can be used by biochemists to understand bioenergetics and by chemical engineers to manufacture plants. Thermochemistry is a very important field of study because it can help determine any particular reaction and if that reaction will release or absorb energy as it occurs.
So, in a conclusion, it should be noted that thermochemistry reactions are an essential part of general chemistry, and in a depth study of this area of knowledge allows not only qualitative determination of the type of reaction, but also quantitative calculations of measurable parameters.